Okay, welcome to your first video. We're going to go over the study guide review to make sure you are ready for your test tomorrow. So I want you guys to first notice the key vocabulary. Absolute value, inequality, integers, negative numbers, opposites, and positive numbers are all key words that we've gone over and over. There is no vocabulary on your test, but knowing what these words mean will definitely help you, especially on some of the word problems on your test. So we're going to go through each lesson that we've gone over and do a little bit in each lesson. So Module 1 was first about integers, and the essential question that we talked about was how can you use integers to solve real-world problems? In example 1, James recorded the temperatures at noon in Fairbanks, Alaska over a week in January. So they give you a table showing the days and the temperatures he recorded. They want you to graph the temperatures on the number line and then list the temperatures in order from least to greatest. So they graphed the numbers for you because this is an example. And then if we're reading the graph from left to right, we can list those temperatures in order from least to greatest. And what you have to remember about a number line is as we go to the right, the numbers get larger. So if I was going to list these numbers least to greatest, I first run into -3. It's the number that's most on the left, so it's the least. If I keep on going to the right, -1 would come next. Keep on going to the right, then I would list my 2. Going to the right, 3 would come next, and the furthest number on the right is 7, so that would be our greatest integer. Example number 2. Graph the following numbers on the number line, then use the number line to find each absolute value. So here again, they went ahead and graphed those numbers on the number line in black. They want you to find the absolute value, which remember what absolute value is. It's the distance from 0, and the bars indicate that they're asking for absolute value. So it's asking how far away is -4 from 0? Well, it's 4 units away. And you have to remember that absolute value is always positive. How far away is 0 from 0? Well, that's just 0. 0 is never, you never put a negative or a positive sign on 0. It's just 0, but it is considered a positive number. How far away is +2 from 0? Well, it's 2 away. Again, distance is always positive, so you're going to put a +2 there. And how far away is -1 from 0? Well, it's 1 away. So again, distance can't be negative. It always has to be positive. In the exercises, now they want you to graph each number on the number line, and all you have to do is go place a dot. So -2, you should have graphed a point on the -2. +5, you should have graphed a point here. +1. And the last one you should have plotted a point on is -1. Okay, on the second page of your study guide, it's asking you to write the opposite of each number. So remember, the opposite of each number is the number that is the exact opposite on the opposite side of 0, but the same amount of spaces away from 0. So the opposite of +8 would be -8. The opposite of -3 should be +3. And the next little section asks us to list the numbers from least to greatest. So you want to think about those number lines that you just plotted. If I was looking at the number furthest on the left, that would be -2. That should have been your least number that you listed. Then 0, then 3, then 4. On number 5, the number furthest on the left would be -5. As I go to the right, I would run into a -3, then a -2, and finally 2 would be the number furthest on the right, so that would be our largest number. Exercises 6 through 9, they want us to use the number line to help us compare greater than or less than. Well, remember we talked about the number that's on the right would always be the larger number. So 4 is on the right of 1. So we want to put our greater than sign. 4 is greater than 1. On number 7, the positive 2 is on the right. So you want to write negative 2 is less than positive 2. Number 8, the number on the right is negative 3. So you want to write that negative 3 is greater than negative 5. And number 9, the positive 2 is on the right. So you want to write negative 7 is less than positive 2. For 10 and 11, they want you to find each absolute value. Again, that's just the distance away from 0 on the number line. So how far away is 6 from 0? It's 6 units away. How far away is negative 2 from 0 on the number line? It's 2 units away. In the next section, we're starting to talk about rational numbers. The essential question we looked at in this unit, or in this module, was how can you use rational numbers to solve real-world problems? And the key vocabulary terms were you had to remember what a rational number and a Venn diagram. You have to remember those definitions, okay? So here's our Venn diagram. We talked about how it shows whole numbers are integers, and whole numbers are also rational. Integers are rational. And then there's numbers that are only rational that do not fit into either one of these categories. So they're giving you examples like the number 1/2. 1/2 is a fraction, so it would belong in the set of rational numbers because it's not a whole number and it's not an integer. B is negative 5, and they're reminding you that negative 5 belongs in the set of integers and rational numbers. For C, it's a positive 4, and 4 would belong in the set of whole numbers, integers, and rational numbers. And then we have 2/10. Our decimal belongs just in the set of rational numbers. Okay, so you will be asked questions like that on your test tomorrow. On the last page of the study guide, the example is showing you how to put rational numbers in order. And in this case, we're going from least to greatest. Notice that they're giving you some fractions and some decimals. So we talked 2 days on how to change a fraction to a decimal and a decimal to a fraction. So the easiest thing to do is to write the fractions as equivalent decimals. So 1/10 would be written as 0.1, and 3/5, remember that we talked about changing the 5 to a denominator of 10. What did I do to 5 to get 10? Times 2. So 3 times 2 is 6/10. So they changed it to the decimal 6/10. And now that we have all decimals, now we're able to put them in order. And I see that 1/10 is the smallest, then 2/10, then 35/100, then 6/10, and last, the greatest number would be 9/10. So they've listed those numbers here in order from least to greatest. Now they want you to order these numbers in order from greatest to least. So you always need to pay attention to the order they want you to go. Again, every time you have a fraction, you should change it to an equivalent decimal. So for 2/5, they showed you, actually here they wanted you to change the decimal to a fraction, and then you would have to get common denominators, which you could also do that. Once they're common, then you can put them in order. If you wanted to change these to decimals and then put the decimals in order, you should still end up with the same answer. But let's go ahead and look at the way that they did it. They went ahead and changed this 2/10 to a fraction, and you do that by place value. You look at the 2, it's in the tenths place, so you put 2 over 10. And what they did was they simplified it. All they did was divide by 2, and they got 1/5. So now that you know that 2/10 is equivalent to 1/5, well, you have 2/5, 1/5, and 4/15. So if you look at the denominators, you have a 5, and a 15. Well, 15 would be the common denominator for all three. So what they did was they said, well, what would I do to 5 to get 15? And you can see times 3, whatever you do to the bottom, you do to the top. Here's the equivalent fraction for that one. What did I do to 5 to get 15? Times 3, whatever you do to the bottom, you do to the top. So they have 3/15. And now that they're 15 on the bottom, now we can look at the numerators to compare. Well, you have a 6, a 3, and a 4. So the 3 would be your least number, the 4 would be in the middle, and the 6 would be the greatest number. So you can also do it that way. Either change them all to decimals like they did on the top example, or change them all to fractions like they did on the bottom example. In the exercises, they want you to classify each number by indicating what set it would belong to. So for number 1, 8 is a whole number. You have to remember that whole numbers start at 0, and they're the counting numbers going up, so they have to be positive. Well, it's also an integer, because integers include whole numbers and their opposites and 0. Okay, they're the numbers on the number line. And it would also be a rational number, and remember the definition of a rational number. It's a number that can be put in the form a over b, and I could put 8 over 1. On number 2, we have a decimal. Well, a decimal cannot be a whole number, and a decimal cannot be an integer. So the only set that number 2 belongs to, 25/100ths, can only be a rational number. In the next section, find the absolute value of each rational number. Remember that absolute value, again, is the distance away from 0, and so it has to be positive because distance cannot be negative. So the absolute value of 3.7 would just be 3.7, 3 and 7/10. And the absolute value of negative 2/3 would just be positive 2/3. Graph each set of numbers on the number line and then order the numbers from greatest to least. So here we're looking at a number line, and the most important thing when you are looking at a number line is that you look at how far away the tally marks are. So if you're going from 0 to a half to 0.5, then that means each one must be 0.1, 0.2, 0.3, 0.4, 0.5. Always know what each mark represents before you start putting these on the line. So for the first one, we have a negative 0.5. Well, that's actually labeled for us on the number line. So you want to graph that with a point. And then we have a negative 1, which is also labeled for us. So you want to plot a point there. Then we have a negative 1/4. Well, here you're going to have to think, well, okay, if 1/4 is really half of a half, and it's negative, it's going to be halfway between 0 and the negative half. It's exactly halfway. So if that's a 0.1, 0.2, negative 1/4 would be here, because negative 1/4 is the same, it's equivalent to negative 0.25. And we talked about 1/4 a lot in class, that you look at that denominator and you say, can I change 4 to a 10, 100, or 1,000? Well, it goes into 100 easily. What did we multiply by to get it to 100? We multiplied by 25. Whatever I do to the bottom, I do to the top, and that would be 25/100ths, which is written as a decimal 0.25. And that's how you would know that these two are equivalent. So if that's a negative 0.1, negative 0.2, negative 0.3, a negative 0.25 would go between the negative 0.2 and the negative 0.3. Because remember, negative 0.2 is the same thing as negative 0.20, and negative 0.3 is the same as negative 0.30. So negative 0.25 would go right smack in the middle of those two. And then, of course, we all know where 0 is, and it's labeled for us, so we would plot our point there. And now we're able to put them in order, and remember they want us to go greatest to least. So the number most on the right would be 0, and then the next largest number would be our negative 1/4, and then going to the left would be negative 0.5, and last we would have negative 1 would be our least because it's furthest on the left. So remember, on the number line, the numbers that are on the left are the smallest, and the numbers most on the right are the largest. Okay, you did have a paper stapled to your study guide, which is going to review you on lesson 2.1, 2.2, and 2.3. So the first one is talking about classifying rational numbers. It says 5 friends divide 3 bags of apples equally between them. Write the division represented in this situation as a fraction. So 3 bags of apples is being divided equally between 5 friends. So the 3 is being divided by the 5 friends. Okay, so if they want us to write the division represented in this situation as a fraction, you would just put exactly what I have there, 3/5. In the next example, it wants you to write each rational number in the form A over B. So for number 2, we have what we call a mixed number because it's a fraction with it's a whole number with a fraction. So in order to change it to the form AB, we have to do Texas to change it to improper. So 5 times 6 is 30. 30 plus 1 is 31. The denominator stays the same, and now I have changed it into the form A over B. For number 3, if I wanted to put this integer in the form A over B, all I have to do is place it over 1. So these two would be considered rational numbers because I can put them in the form A over B. Next it says determine if each number is a whole number, an integer, or rational. Include all the sets to which the number belongs. So for number 4, I have a negative 12. Negative 12 is an integer, and it's also rational. It's an integer because integers include all whole numbers and their opposites, and this happens to be the opposite of a whole number 12. And rational because it can be put in the form A over B as we saw here. The next one is 7/8, and it's a fraction, so it can't be a whole number. And since it's a fraction, it's also not an integer. So the only set to which it belongs is rational numbers. In lesson 2.2, we learned how to identify opposites and absolute value. And so again, on number 6, they're asking us to graph these rational numbers on the number line. Negative 3, you're going to plot a point. 1 3/4. Okay, so that's going to be between the 1 and the 2. 3/4 is pretty close to a whole, pretty close to 4/4. So it's larger than half, but not quite there. So you should put it right before the 2, and it's positive. So we're going to go ahead and label that is 1 3/4 because this was labeled for us, but this was not. The next one they want us to graph is negative 0.5 or negative 5/10. Actually there's a typo on this number line. There should be a negative sign there. Negative 5/10 would be before you get to the negative 1. So notice it's not the whole, it's not -5, it's -0.5. So it would be right in the middle of -1 and 0. So go ahead and label above that would be our -5/10 up there. And then they also want us to plot a +3 on this number line. So be sure you can plot numbers on the number line in the correct place. Number 7, it wants you to find the opposite of 1/3 and -7/12. Well, the opposite of 1/3 would be -1/3. That's one answer. And the opposite of -7/12 would just be +7/12. Remember, opposites would be equal distance from 0, but on opposite sides of 0 on the number line. Number 8, find the absolute value of 9 8/10 and -10/3. So go ahead and draw the symbol for absolute value on your numbers. The absolute value of 9 8/10 would just still be 9 8/10. That's the first answer. And the absolute value of -10/3 would just be +10/3. You don't have to simplify it since that's the form they gave it to us in. And it's just asking for absolute value. For section 2-3, it's asking us to compare and order rational numbers. So there's a word problem we're going to read. Over the last week, the daily low temperatures in degrees Fahrenheit have been -4, 6 2/10, 18 1/2, -5 9/10, 21, -1/4, and 1 75/100. List these numbers in order from greatest to least. So you'll see that I have some integers, I have some decimals, I have some mixed numbers, and I have fractions. You have to make them into the same form. So I think it's easier to change them to decimals at this point. Pretty easy to change them to decimals. So 18 1/2, if you don't already have that committed to memory, that a half is the same thing as 0.5, then you can show your work by saying, look at the denominator. I can easily change 2 to the 10th place. What did I do to 2 to get 10? Times 5. Do the same thing to the top. What's 1 times 5? 5/10. How do I write 5/10? 0.5. Well, if the 18 is a whole number in front of your fraction, then the 18 is a whole number in front of your decimal. Okay? Now look at this fraction, -1/4. We looked at 1/4 earlier in this review. I'm going to put it up here. Look at the denominator. Can that 4 change to a 10, 100, or 1,000? It can change to 100. What did I do to 4 to get 100? Times 25. So 1 times 25 is 25 hundredths. That would be 0.25, but again, that's negative. Excuse me. Okay, so now that they're all decimals, we can put them in order. If I'm going to go from greatest to least, I want you guys to think of a number line. Which number would be most on the right? That's the number you're going to list first, and that would be 21. Then as you start going towards the left, what number would you run into next? It would be 18 1/2. Even though we changed it to a decimal, we know that we need to give the original number back in our answer. If I keep going to the left, what number am I going to run into next? It would be 6 2/10. After 6 2/10, I would run into 1.75, and then I would run into -1/4. Then I would run into -4, and last would be -5. and 9/10. The only part where I could see this getting a little bit tricky is maybe here. When you're looking at, well, what's bigger, a negative 1.75 or a negative 1/4? You have a 1 in front of your decimal, and here it's just a negative decimal. So the 1 is going to be larger than our negative 0.25. Okay, and then as you keep going to the left, you're going to run into the negative 4, and then finally way on the left of the number line, you're going to run into the negative 5.9, so that's the least number. So this gives you a good overview of the major concepts we went over in this unit, and that's exactly what you're going to be tested on, all these concepts. So I wanted you to compare your answers that you got on the study guide with this video, and be sure that you fix anything that you got wrong so that you'll be ready for that test tomorrow. See you tomorrow.